So thank you, everybody, for having me today. I'm absolutely delighted to speak at this webinar. My name is Aileen O'Connor, and I work for an organisation called Food for Health Ireland. And my role involves overseeing some of the human intervention trials here at the University College Dublin in Ireland. So today I'm just going to speak to you about the dairy matrix effect from a nutrition perspective. So firstly, I'm just going to give you a brief background on Food for Health Ireland and who we are, and then we will look at some of the evidence surrounding dairy foods and health, as well as evidence behind the dairy matrix effects. And I'll also discuss with you some of our current research where we investigate the dairy cheese matrix on markers of metabolic health. So who are we? Who are FHI? So we are a collaborative innovation centre that brings together leaders in industry and research to help improve global health through novel functional foods and ingredients. And our partners include a number of research organisations here in Ireland, including University College Dublin, and also a number of Irish food industry partners. And our research aims to address the global food trends and challenges. And as I mentioned, we are focused on the development of functional foods and food ingredients, providing potential health benefits. So some of our target markets include infant nutrition, healthy aging, and performance nutrition. So at the moment, our primary focus consists of 4 pillars. So we have a fermentates program that is conducted to enhance digestive health, nutrient absorption, and also to reduce gut inflammation through many bioconversion technologies. We also have a grass-fed dairy program where we are examining the differences of grass-fed versus total mixed rations or grain-fed dairy on nutrition and health. And thirdly, we have our healthy cheese program where we are continuing to research the effects of Irish cheese on metabolic and cardiovascular health. And then lastly, our final program then has a translational focus. So to maximize bringing science and products to market in order to enhance particular aspects of health. So that's us in a nutshell. So now I'm just going to talk to you a little bit about the evidence behind dairy foods and health. So when we think of dairy products and nutrition, one of the main nutrients that probably comes to mind is calcium, but dairy is also a substantial contributor to saturated fat intakes, which has been a common concern for consumers over the years when consuming some forms of dairy. So there has been a lot of concern and research has debated over saturated fat intakes and its association with chronic disease risks, such as coronary heart disease. So some early studies, very early studies driven by Dr. Ansel Keys, they investigated the links between coronary heart disease mortality and lifestyle factors, especially the intake of saturated fatty acids. So the results show a correlation between saturated fat intake and coronary heart disease. And the study pointed out the major differences in disease rates in relation to the amount of saturated fat intake, where the countries with a high intake of saturated fat also had a significantly higher number of coronary heart disease deaths in relation to population size. Now, more recent meta-analyses, more recent research is coming out. So for example, in 2015, D'Souza found that of 6 prospective studies that examined the association between intake of saturated fats and all-cause mortality, the most adjusted multivariable risk ratio was 0.99, which actually suggests a wide variation in the studies. And overall, there was actually no association. And there have been a number of meta-analyses published and systematic reviews since looking at dairy products in relation to CVD risk. So work by De Good in 2016, they carried out a dose-response meta-analysis of dairy consumption and risk of stroke. And they concluded that milk and cheese consumption were overall inversely associated with stroke risk. We also had another dose-response meta-analysis by Gua et al., and they looked at milk and dairy consumption and risk of CVD and all-cause mortality in prospective cohort studies. And they combined the data from 29 prospective cohort studies and demonstrated neutral associations between dairy products and cardiovascular and all-cause mortality. And then we had Alexander et al., another study in 2016 that looked at dairy intake and the risk of CVD, stroke, and coronary heart disease. And they also indicated that the consumption of various forms of dairy products shows either favorable or neutral associations with these clinical outcomes. And then another study in 2018 by Dagood again, they looked at dairy consumption and cardiometabolic diseases, also found neutral and beneficial associations between dairy products and the risk of type 2 diabetes, stroke, and coronary heart disease. So there is this large body of evidence that exists examining the impact of dairy consumption on markers of metabolic health. And although there are some mixed findings, many seem to suggest that the dairy consumption provides either a neutral or a beneficial role. So now I'm just going to discuss with you the concept of the food matrix, specifically the dairy matrix. So moving beyond just looking at single nutrients and looking towards a more holistic and more whole food approach when it comes to diet-related health and disease risk. So moving beyond these single nutrients, so why is this important? Well, traditionally, the study of nutrients and health has taken a reductionist approach. And what this means is this type of approach links single nutrients to single health effects. And while this is important in our understanding of the role of nutrients in the body, it doesn't allow for the study of the interaction of those nutrients. So some examples of this are almonds. We have a really nice couple of examples here. So there's a couple of studies done looking at almonds and how the particle size, so through chewing, can affect the degree of the energy extracted. Now, there's also some evidence to suggest that this can even impact things like the allergenicity of the proteins. And another non-dairy example is that of carrots and nutrient bioavailability. So in 2002, a group of researchers examined the availability of carotenoids in carrots, and they found that when simulated digestion of raw, large bite-sized pieces, just 3% of total available carotenoids had actually recovered. But when it was homogenized, up to 21% had recovered. So this just shows the importance of matrix. And interestingly, when they were actually cooked with oil, up to 39% total carotenoids were recovered. So it also just demonstrates that it's not just the food matrices, but it's also dietary patterns that are key here. And then we have some previous dairy examples include matrix effect, such as yogurts, where the fermentation process develops acidic properties, which can influence the mineral absorption. And then we also had a study conducted by Soko et al. In 2016, and they also found a potential wheat matrix effect on the tolerance of baked milk in a small sample of children who had immunoglobulin E cow's milk allergy. So what is this dairy matrix? So Forney et al. Describes the food matrix as foods that consist of a large number of different nutrients that are contained in a complex structure. And the nature of the food structure and the nutrients therein, so i.e. the food matrix, this will determine the nutrient digestion and absorption, thereby altering the overall nutritional properties of the food. And these matrix effects seem to be very, very apparent in dairy foods. And this is why it has been coined the phrase, the dairy matrix. But it's also important to understand that not all dairy foods are created equal and not all dairy foods are the same. Yet in our food-based dietary guidelines presented as a plate in many European countries or a food pyramid, milk, cheese and yogurt are generally grouped together on the same shelf and they are considered the same. And this is common practice in other food-based dietary guidelines across Europe and around the globe. But even these groupings are really oversimplistic, and there is this wide variety of dairy products. There's different types of milk, there's different types of cheeses and yogurt, and especially cheese. And the matrices within these products also vary considerably. So they differ in terms of their structure, their fat content, their protein content. Like there are other important other components present in numerous amounts, such as phosphorus, calcium. You also have a complex structure known as the milk fat globule membrane, as well as bioactive components such as bioactive peptides. So we know milk and dairy products are naturally rich sources of a wide range of nutrients, such as fats, proteins, and a number of micronutrients. And this diagram just gives an overview of the nutrient content and the associated health benefits of dairy consumption, which many of you are, well, most of us are already aware of. And it just demonstrates how the nutrient composition across the range of products varies greatly. So some of the main nutrients include calcium, which plays an essential role in bone and teeth development, which we all know. You also have vitamin B12, which keeps our body's nerve and blood cells healthy. And then you have protein, which is well known for providing structure and growth and repair for the body. And then we also have potassium, which helps to regulate fluid balance and muscle contraction. And also phosphorus, which is very important in bone, teeth, DNA, and RNA. But while dairy has been shown to have, to contribute beneficially to the diet, dairy foods also contribute significantly to sodium and saturated fat intakes. And we know high sodium intakes is a prominent factor for the development of hypertension, and high intakes of saturated fat are associated with elevated levels of LDL cholesterol, both of which are strong risk factors for cardiovascular disease. And because of these perceived health effects, consumers are particularly concerned with these nutrients within the dairy products. So now if we look to the dairy guidelines in relation to dairy fat within the Irish diet, dairy foods contribute to about 13% of total fat and 20% of saturated fat. And for this reason, many of the guidelines recommend 3 to 5 portions of dairy per day, advising low or reduced fat dairy. And currently in Norway, it is recommended to limit the use of dairy products that contain high levels of saturated fat, such as full cream milk, cream, fatty cheese, and butter. But many dairy products are not that high in fat. So if you look at milk, it's, full fat milk is 3.5% fat. That's not very high. Yogurt, 1.5%. That will vary depending on the type of yogurt, but not by much. And then again, cheese, 25%, that is quite high, but again, that will vary significantly on the cheese. So it is important to look at the food source of saturated fat as well as the specific types of saturated fat. And in terms of dairy products, nutrient content varies significantly. So this box plot here is taken from a recent review by Timon et al. And this shows the average fat and mineral content in dairy products per 100 grams. So the values are taken from the COPA database, and they're used to compare nutrient composition across a range of commonly available products. So you can see here that there is a significant variation of fat and mineral content across each of the dairy products, with cheese displaying the highest and the largest range in mineral content and a significant amount of fat. So again, this just reiterates how much dairy products vary in terms of their nutritional content. And again, they're on the same shelf, they're considered equal. So now I'm just going to bring you through our own dairy fat matrix intervention study that we carried out a couple of years ago, where we investigated the effect of dairy fat consumption on markers of metabolic health. So a number of randomized controlled trials have associated cheese with lower levels of blood cholesterol compared to other products, especially butter, and the current supporting evidence suggests that cheese consumption might be associated with a reduced risk of CVD. So therefore, our hypothesis for this matrix study was that the dairy fat consumed in different matrices would have different effects on LDL cholesterol and other markers of metabolic health. So the intervention study consisted of 42 grams of dairy fat across 3 different matrices. So we had Group A, which consisted of 120 grams full fat cheddar cheese. Then we had Group B, which was a low fat cheddar cheese, and also 21 grams of butter. Our Group C was our control group, and that contained 49 grams of butter, a protein powder, and a calcium supplement. And then Group D was the same as Group A, except they had a 6-week run-in period where they abstained from eating all cheese up to that point. So all of these intervention diets were matched as closely as possible for their total energy, their macronutrients, and their calcium. And the figure here shows that the change in lipid profiles after the 6-week intervention And of the 164 participants who completed the 6-week intervention, compliers were only included in this analysis. So this total was 127. And interestingly, we found this stepwise matrix effect between the groups for total cholesterol and LDL cholesterol, with significantly lower post-intervention total cholesterol and LDL cholesterol when all of the fat was contained within the cheese matrix, which was our diet A, when compared with diet C, which was our control group. And there was no significant differences observed then between the groups for HDL. So this really echoes previous randomized controlled trials that the consumption of saturated fat in the form of cheese has different effects on blood lipid profiles compared with the same amount of saturated fat eaten in the form of butter. Now, I suppose I'm going to add another layer onto this, adding more complexity when looking at the risk markers of cardiovascular disease. So traditionally and typically, increased LDL levels increase the risk of CVD. But research has also shown that those with a normal range of LDL levels can also develop atherosclerosis and CVD. And this variation in the risk and the response can be due to the heterogeneity of the LDL particles with regards to their size and their chemical composition, as well as their density. So you have, on one hand, you have small, dense LDL particles that can easily gain access to the inside of the wall of the artery where they can cause damage. And then on the other hand, you have these large, buoyant LDL particles that are just too large to get through the wall of the artery, and then therefore they're classed as harmless. So we carried out some secondary analysis on our primary study a couple of years ago, and these figures here show NMR analysis of LDL particles at our visit 1 and our visit 2 across the matrix groups. And the bar graphs show that total LDL particle concentration in figure A, you then have your medium density in figure B, you have your large LDL particle concentration in figure C, and your small LDL particle concentration in figure D. And the concentration of the total LDL particles here, seen in figure A, they significantly decrease on intervention across the groups. And this was consistent with the reduction in LDL levels we saw in our primary study. And there was also this trend towards a reduced concentration of small LDL particles and medium particles. And this was also evident across the groups, but there was no trend that we found for the large particles. So there's a reduction in total LDL particle concentrations, but when we look at the subclasses, so when we look at small, medium, large particles, we see that this reduction is mainly in the small pro-atherogenic LDL particles. And after our dairy fat intervention, there was this transition towards a more positive lipid profile. So there was lower small LDL particles, and then there was also the preservation of large buoyant LDL particles. And then again, to add further complexity to this, we also need to consider the potential inter-individual variation that may influence the response. So there is a number of physiological and environmental factors that can influence the individual variance in response to food consumption, but we just don't know a lot about the extent of this variability. And another paper that we have in prep at the moment is further secondary analysis, where we wanted to examine the lipid response in our dairy fat intervention and to try to determine the factors associated with this lipid metabolism response. So we looked at response in a couple of ways. We based the percentage change on total LDL and HDL cholesterol post-intervention, and then we also looked at the change in clinical risk. So basically, who went from not meeting the cholesterol target limits to then meeting them after the intervention. And we found that participants demonstrating the largest decrease in total cholesterol had a significantly higher level of total cholesterol and LDL and lower levels of triglycerides at baseline compared to those that didn't respond. And in table 4 here, if you look to the left, we looked at predictors of the different cholesterols, and we found that the variation in the percentage change in total and LDL was associated with baseline total cholesterol triglycerides, body weight, and our high sensitivity C-reactive protein. And then further, if you go to table 5 on your right, this shows the population meeting the cholesterol levels or the cholesterol cutoffs presented by the World Health Organization. So the percentage of the population meeting the recommended total and LDL levels nearly doubled following the intervention, with total cholesterol increasing from 16 to 31% and LDL increasing from 24 to 37% following the intervention. And this change was greatest in Group A, which you can see here, and this was our solid full-fat cheddar cheese. So I suppose overall, this just suggests that the individual's phenotype, including their biochemical factors, specifically total and LDL cholesterol, as well as your triglycerides, can potentially influence the response to dairy fat in some individuals. So from all of this body of knowledge that we have, it just shows how complex dairy intake and metabolism is, and it involves a number of factors. So we have food matrix effects in terms of saturated fat intake. We also really need to look further into the specific types of saturated fat before we make decisions on entire food groups. So for example, stearic acid in dark chocolate. You also have humidic acid in meat, and you also have heptadecanoic acid in dairy products. Like all three of them, they are all completely different physiological, they all have completely different physiological effects. And the the food matrix in which the fatty acids exist is also important for these effects. And then you also have cholesterol, which can be further broken down into their different particle size. And they also react differently from each other. And then on top of that, you have your individual response, which varies considerably. So this also goes wider again, and we really have to consider not just the foods, not just the nutrients, but it spreads to wider areas such as your eating occasions and your dietary patterns. And all of these factors are important, and the interaction between them are important for overall health. And in response to the potential effect of food matrices, instead of using the traditional methods of examining single foods or single nutrients, dietary pattern analysis has been suggested to provide more insight into this complex relationship between dietary intake and disease. So I suppose the collective effects of all of the dietary components within a particular dietary pattern can interact with each other and become more influential than a single nutrient. And this could have implications when, if you're investigating the relationship between one nutrient and chronic disease. And this can potentially cloud the true results that we're actually seeing. So looking at dietary patterns also needs to be considered, and it could be a really effective approach to help reduce diet-related chronic disease risks. And there's many dietary patterns that are well documented and have demonstrated to show protective effects, such as the DASH diet, the Nordic diet, and the Mediterranean diet. And then based on our own work and our recent evidence surrounding the dairy matrix, we really have to ask, is the recommendation to limit all full-fat dairy products necessarily the best advice? I'm not sure that it is. So you have to ask, is it based on the totality of evidence? And it's been 7 years since the last report was carried out, and there's a lot more evidence that has emerged since, and demonstrating that it is not just the saturated fat content, but also the foods and the matrices that the nutrients are contained in are really important. So, and there are obviously all of the beneficial nutrients in dairy products as well. So limiting the consumption of dairy products could I suppose, have a knock-on effect and have a consequential adverse effect on health in other areas. So we really do have to be careful. So in summary, there is a large body of evidence that we know of examining the impact of dairy consumption on markers of metabolic health. And the food matrix is the concept that foods consist of a large number of different nutrients, and they're contained in a complex structure. And as the nutritional and the physical properties of foods can affect digestion and absorption, they can exhibit different actions than the corresponding actions of the individual food components. And in terms of the dairy matrix, we know that the dairy products are not all the same in composition or in physical structure, and they have differing effects on metabolic health. And then finally, the results from our own dairy fat matrix study suggest that dairy fat held within the cheese matrix may have beneficial effects on blood lipid profiles, particularly LDL cholesterol. And we also need to consider the particle size in our LDL cholesterol, and we also need to consider the individual response and the inter-individual variance. This also needs to be considered. And then lastly, dietary patterns may also give us more insight into this complex relationship between dietary intake and disease, and the collective efforts of all of the dietary components within a particular dietary pattern can interact with each other and potentially become more influential than this single nutrient. So I'd like to thank everyone on our cheese study team and the wider FHI team for all of their work and support. And I would like to thank everybody here today again for having me. And I look forward to answering any of your questions.